Okay, bad backend choice. And welcome to this new chapter. We're gonna talk about bad choices you might make on a backend language. Understand one thing, please, that all of these things are relative. It might be not correct for someone and correct for somebody else, but from a neutral point of view, we're gonna discuss all these content. So what are the bad choices in the backend language selection? And the first one goes for choosing a scripting language. Scripting language is for scripting, is not for building a software. And I have seen a lot of softwares built perfectly fine on top of a scripting language, for example, WordPress or Magento. These are great softwares serving a lot of people, or even Wikipedia, and all of these work just perfectly fine. But usually, using a scripting language causes damage to the project. One thing and major issue with these are they usually are not type safe. So if you're not type safe and if you're not having kind of a strict programming language limitations on how the data is stored, how the data is moved, over time the quality of software will decrease and decrease. Another issue with the scripting language is they usually do not generate binaries directly. Consider Node.js. Node.js, JavaScript, you run it and it's gonna be working fine on the back end. You could write a desktop application with it. But since it does not provide binaries, it has a lot of problems. In terms of distributing the app, it's very hard to distribute the Node.js app without the source code. You're just going to give the source code to somebody, to your backend team, to your DevOps team, publicly, and then they have to install the Node.js themselves and run it. Obviously, it is possible to bypass this, make a package or bundle, and then maybe use Docker. But all of those things are absolutely unnecessary if you are not using a scripting language. And performance is another thing with these languages. They are usually not as fast. Now, lots of companies, lots of projects really do not need that much of a performance. And they might skip that. But in the end, why you want to do that in the first place? Because if you could get like a backend running with less than 10 megabytes of file disk, and then 5 megabytes of RAM and no CPU usage and idle, why you want to go for something which is really resource heavy and has a lot of strings attached to it. The second thing is choosing a language which works in a specific setup or cannot be compiled directly. What does that mean is it's not only scripting languages do not compile to binaries, it's also like Java and C#, they do not compile. Yeah, they're compiling into some intermediate bytecodes or something, and in case of JVM, it is extremely fast, and sometimes it's even faster than C and C++ in some computational work because it is perfectly tuned and perfectly significantly invested on the compiler for optimizations. But there's a problem with that. Usually the software you build requires a lot of content from them, requires a lot of infrastructure to be able to running. For the C# you need to have installed a couple of different C++ framework, couple of different .NET framework. For Java it's the same, it doesn't work out of JVM. Then if you write in Java, you can't use it on iOS. And these kind of things are perfect for one scenario, but they usually do not support the other scenarios. And because they don't provide the binaries, the software does not really last that long. It really depends on the version of the JVM and all those things, which might not be a problem in a lot of projects, but in things I like to build, it is a real issue that you need to be able to only work on Windows, or if you're writing on C#. Now, there might be a way to just run it on Mac or Linux, but again, why you want to do that from the first place? And third thing is, I think we discussed already, if you are not having a type-safe language, It just allows bad practices, and it's just going to damage your software quality over time, allowing you to do bad things, allowing you to do like calling to functions which do not exist or they're not compiled. It's going to be extremely hard to separate software. Now, the best thing I ever seen is a C language. So we can have macros and then use if-def and just separate the code for a specific operating system. Just you can't do that easily in a scripting language, and allows you to do things which later on you just realize, oh my god, this module cannot be separated or added somewhere else. It's going to keep you in very, very specific scenario. And the fourth option is choosing a language which is really vendor specific. Kind of falls into the second item on the list, but for example, C# and Java again, they're really, really vendor specific. So if you're C#, then you're in Microsoft world. If you're Java, you're in JVM world, Java world. And you really don't want to be stuck in one of these, especially if you're a software house or company that builds their own very first product. They don't know what's going to happen later on. They're going to change something later. It is really, really limiting, and you will realize that down the road. Now, what are the options to choose? Like, what are the best options for building software? I think now are Node.js, PHP, Java. It's not on the slide, but I think Node.js, PHP, Java, Golang, C, and C#. But my choice is Golang, and I'm going to describe the issues with each real quick. PHP is a scripting language, and it allows like not type safe things. It does not compile. It's super slow. It's easy to work with. So just does not qualify itself as what I really like to have as the main primary programming language. Java is fast. It's compiled, but it has a lot of dependencies. If you want to create a desktop app, oh my God, God helps you. And it's really vendor specific. So if you write Java, it just does not work on iOS, or if you've written in iOS, it wouldn't work in Java. It's limited. Golang is something great tool. Problem with it is there are not much developers for that. It's compiled. It's very fast, but it is slower than Java. And it does a lot of things that C does not do. The other option is, what I think is the best option, is C or C++. But the main problem with that is it's just going to be compiled very slow in comparison with Golang or PHP, which does not really need compilation. And it's extremely hard to be accepted in a backend or web industry. Just people do not go for that level of details. And C# also is having similar issues with the Java. Therefore, I just decided to have Golang as the primary backend language. It's because it's really easy to build a desktop app. Like, probably heard about Electron. And it just gives a lot of large, like RAM consumer binaries, and it's really slow in many scenarios. You might be using like apps with that and just see how slow things get over time. Especially if you don't have very sophisticated computer configuration, and all those things just hit you in the back. And Golang can run also in Android and iOS. We will be discussing about it. I'm going to show it, how it does such thing. And finally, it does not really belong to any special operating system. So if you're working on Mac, Windows, that's Linux, works all perfectly fine, except the microcontrollers, and you really don't want to write any Golang on microcontrollers anyway. Thank you so much for this chapter, and after a quick break, see you on the next one.